Hi, this is Sadish Kumar from Coconut College of Engineering and Technology. We are going to discuss about subject soil and water conservation engineering. In this, we are going to discuss now Unit 3 erosion control measures. In this, we are going to cover the topic agronomic practices such as contour cultivation, strip cropping, tillage practices, soil management practices, then bunding, types, design, specifications and of bunding, then mechanical measures for hill slope, then terracing, classification, design specification of bench terrace, grassed waterway, location, construction, maintenance, types and permanent temporary gully control structures. These are topics we are going to discuss under this unit. Then soil conservation is an preservation technique in hilly regions to conserve the soil from the raindrop impact, so that soil conservation is very essential. Then agronomical measures as contouring, strip cropping, tillage practices. In the contour cultivation, contour farming is an farming with row patterns that run nearly level ground around the hill, not up and down hill, reducing the runoff, soil erosion and increasing fertility. They all key benefits of the contour farming. Yet to practice has also shown in the increase in the crop yield. This kind of hilly region cultivation is to be called as contour cultivation, which is shown in our figure. This kind of also followed in our South Asian countries for cultivating the crops in the hilly region, so that it will be very effective for water conveyance in the field. Then low rainfall regions is need to conserve the water, so that the contour lines are located at a distance of 25 meter to 33 meter depending on the steepness of the land. First contour line is to be generally fixed about 50 meter apart from the top of the hill, then only we can utilize it. Then objectives of contour cultivation is to reduce the sheet and rill erosion, reduce the sediment transport and other solid nutrients, to enhance the infiltration rate. Then criteria for contour farming, then minimum row grade, that is the level of row grade is taken into consideration as an important criteria for contour cultivation. Maximum row grade, to have better result, the maximum row grade should be exceeded either one half of up and down hill slope used for conservation of planting, 10%, whichever is lesser value. Then minimum ridge height, it is decided based on when the row spacing is more than 10 inches. At this level, the row of spacing is minimum ridge height should be 2 inches during the rotation period, which is normally being most vulnerable period for occurrence of sheet and rill erosion. When the row spacing is 10 inches or less, the first row spacing is minimum ridge height should be tuned to 1 inches for close crops like small grains, provided that the height of plant at least 6 inches and the spacing between the plants within the row is not more than 2 inches during the most vulnerable period of the rill erosion. The next one is design consideration, that is rainfall depth and its frequency, then ridge height, row grade, slope, steepness, then hydrological soil group, cover and roughness, slope length. Then limitations of contour farming, it is suitable for uniform slope, not suitable for irregular topographical features. Grassed waterway in conjunction with contour farming system is essential to reduce the possibility of gully development in contour cultivated land. When and where contour cultivation is adopted, depending upon the slope and soil characteristics, types of crops grown, rainfall of the area, most efficient reducing the runoff and soil erosion from the gentle land slopes. On steeper slopes, water accumulates behind the ridge until it breaks, results rill and gullies formation. Steeper slope erosion becomes severe. Limit of land slope and its length suitable for successful contour farming. Greater length of slope used for permeable soil. Apart from no till or reduced tillage practices and more protective covers, crops are used for safe contour farming. Then these are the slope which is to be recommended for maximum slope length. For the slope 1 to 2 they utilize 120 meters, 3 to 5 90 meters, 6 to 8 60 meters, 9 to 12 35 meters, 13 to 16 25 meters, 17 to 20 18 meters, 20 to 25 15 meters slope is to be recommended for cultivation. Then contour tree planting advantages. The line of tree planting prevents the washing of soil and down and slope due to rainfall flow, remains the topsoil in the field and thus maintains the soil fertility. The trees provide fodder for the animals and fuel for domestic uses. Disadvantages: if the trees are not pruned regularly, then there is development of shading effect over the intercrops grown. Tree roots can create the problem in plowing operations, so that contour farming have some this kind of disadvantages. Then contour ridging, reduction of soil erosion 30% in 1 to 8% slope. Effectiveness get decrease with the increase in slope. It interpret the following rainwater and reduce the velocity. Another solution is contour tide ridging. A series of pans and ties are constructed perpendicular to ridges. For better results, ties should be constructed at an interval of 1 to 5 meters. So these are the some of contour cultivation which is practiced in the field. So this is about contour farming types: mulching types, strip cropping, cover crops, vegetative crops, terrace farming. Then first one is mulch farming. Mulches are utilized as one of the important criteria for avoiding the shrubs in the soil medium to protect our layer from it. Also protect the soil shrubs and also it will protect the soil erosion. Only crops will be grown. So different materials for mulching as cut grasses, straw materials, wood strips, sawdust, repairs, sandstones, glass wools, metal foils, cello pans, stones, plastics. Then types of mulches: natural, synthetic, petroleum, conventional, inorganic and organic mulches are to be utilized. Nowadays that synthetic is to be followed most of the times for effective cropping pattern. The next one is strip cropping. The ordinary crops are planted, grown in the field of respectively narrow strips across the land slope. These strips are so arranged that the strips of close growing crops are always separated into the erosion of resistant crops. This kind of strips is to be followed for effective cropping pattern. This is also followed in southern Asian countries. This kind of strips are to be very effective for better crop yields too. The most effective measures in certain soil and topography, more effective in erosion control when it is followed with crop rotation. It forces to infiltrate to soil. The more sensitive practices for rainwater conservation. It is suitable for length slope is not too longer. It makes obstruction in flow path to so dissipate kinetic energy. Reasons for strip cropping: reduction in the runoff flow through the close growing sod strips, increasing the infiltration rate under a covered cultivation. This is about sodding. Sodding is followed for better crop transplantation. So strip cropping crops provide an obstruction in flow path surface water. The root system of the crops makes the soil more porous and causing more amount of water is absorbed by the soil and thus reduces the runoff and soil loss. The water also gets additional intake path along the roots of the plant, which creates similar effect on runoff and soil losses as a previous case. Then advantages of strip cropping: in addition to control of soil erosion, soil loss, the strip cropping is also very effective to maintain the soil fertility and creating the effect on several good farming practices including the crop rotation, contour cultivation, proper tillage, stubble mulching, cover cropping mainly. Then suitable crops for contour farming as rain-fed areas, then life of the crop, then canopy and root characteristics. So based on this, soil erosion will be suitable for our strip croppings. Then types of strip cropping: types of contour strip, field strip, buffer strip and wind strip. First one is contour strip. Contour strips are planted in strips along the contour at an ridge angles to the direction of the natural and land slope. The growing crops are in strips is definite rotational sequences. This kind of crops rotation is to be followed for contour strip cropping. So contour, it looks like a contour cultivation. Then field strip cropping, it is modified from form of the contour strips. Their crops are laid parallel to the land slope depending on the land situation. It is shown in our drawing. The direction of prevailing wind is there. They will cultivate it which is perpendicular to that wind is direction. So this kind of rows are to be followed, uniform slope uniformly followed for stopping the soil erosion. Then buffer strip cropping, the strips of grasses or legume crops are laid between contour strip crops in regular rotation. Width of these strips may not be an uniform. These strips are 2 meter to 4 meter wide and placed at 10 to 20 meter interval. The main purpose is to protect the soil erosion. This kind of figures are there. Uneven strips are to be stripping crops are to be followed. In between that they will provide some empty spacing for that crops. Then next one is wind strip cropping. Hence the strip crops of uniform width are laid at the right angles to the direction of wind without regard of the contour. The objective of this system is to prevent the soil from wind erosion rather than water erosion. It is suitable for level or nearly level topography where wind erosion is more effective. So this kind of wind barriers are recommended for different widths for different types of soils. For sandy soil 6 meter, loamy sand 7 meter, loamy sandy loam 30 meter, loam 75 meter, silt loam 85 meter, clay loam 105 meter. Cover crops are to be followed different crops. In agriculture, cover crops are the plants that are planted to cover the soil rather than for purpose of being harvested. Cover crops manage the soil erosion, soil fertility, soil quality, water, weeds, pests, diseases, biodiversity and wildlife in the agro ecosystem. The functions of the cover crop is to add organic matter into the soil through the roots and plants, to enrich the soil nutrition, to improve the physical condition of the soil, to check the water and wind erosions, also to conserve the plant nutrient by taking up the soluble elements. The next one is terrace farming. Terrace cultivation is the method of growing crops on sides of hills, mountains by planting on the graduated terraces built onto the slope. That is terrace farming. It looks like a contour farming. Instead of that, they will frame some terraces. In this terrace, they will cultivate it. The developed land will be utilized for terraces. Then vegetative waterways. The waterways which is to be vegetated seen in our drawing. The first drawing will not have any vegetation in the water path. In the second drawing, they have some vegetation so that soil erosion is to be stopped. The vegetated waterways are the natural or constructed waterways shaped to required dimension and vegetated for safe disposal of the runoff water from the field diversion, terraces and other structures. Then next one is tillage practices. The term conservation of tillage include the reduced tillage, the minimum tillage, no tillage, direct till, mulch tillage, truss farming and strip tillage. Tillage is defined as mechanical manipulation of soil to develop a favorable environmental for good germination of seeds and crop growth, to control the weeds, to maintain the proper infiltration capacity and soil aeration. Tillage makes aggregation, surface sealing, infiltration and resistance to erosion. Some of the points to be considered during tillage practices: till no more than necessary, till only when the soil moisture in the favorable limit, vary and the depth of ploughing based on that. Then types of tillage practices: deep ploughing. This kind of deep ploughing also is followed. It is showed in our drawing. Some more depth is to be utilized for the heavy vehicles. We can modify it up to a depth of more than 50 centimeter. Ordinary ploughing should not exceed more than 20 meter. The purpose of deep ploughing is to modify the soil returns and characteristics over the long term ploughing, subsoil and year round tillage. The subsoiling is defined as non-intervention tillage. below the depth of 14 inches. The subsoiling is the soil management strategy commonly used by farmers to minimize the soil compaction and minimize crop protection. Year-round tillage is every year they will carry it out. The tillage operation carried out throughout the year are known as the year-round tillage. In dry farming regions, field preparation is initiated with the help of summer showers. Repeated in the tillage operations are carried out until sowing of the crops. Then engineering measures for bunds. Bunds are utilized for protecting the structure while running the flooded water. Bunds are an embankment-like structure constructed across the land slope. When they are constructed, contour area called contour bund. When graded provided called graded bund. Then types of bunds, then contour bund, side bund, lateral bund, supplemental bund, marginal bund, shoulder bund. This kind of bunds are there. Contour bunds are constructed exactly on the contour. Side bunds are formed at the extreme ends of the contour bund running along the land slope. Lateral bunds are constructed between two side bunds along the slope for preventing the construction of water one side, and also break the length of the contour bund into the conventional bits. Supplemental bunds, the bunds constructed between two contour bunds to limit the horizontal spacing by its maximum extent, and marginal bunds are formed at an marginal of the field, road, river, etc. demonstrate their boundary. Then shoulder bunds are formed at an outer edge of the bench terrace to hold the runoff water over the top surface, top terrace. Then next one is classification of bunding system is based on the contour, based on the graded, narrow base and broad base is based on the contour bunding. And also for graded bunding, narrow base and broad base are there. Design criteria for bund construction is land submergence, water conservation, economy of construction, critical length, seepage consideration. Engineering measures in terracing used to control the soil loss at highly sloping lands. It involves construction of embankment or ridge and steps like structure across the slope to check the flow of runoff and control the soil loss. Terrace can be classified into type 1, type 2, type 3. Likewise, classifications are there. Then bench terrace are the platform like structure which are constructed along the contour of the sloping land. The sloping range 6 to 33%. The objectives of bench terrace is to reduce the quantum of overland flow, to minimize the soil erosion, to conserve the soil moisture, to conserve the soil fertility, to improve the intensive land use. Some locations and conditions for bench terrace: areas with severe erosion hazards, areas with small holdings, and areas with food storage, areas where crops require food irrigation, in areas where relatively deep soil there, on the slopes not exceeding 25 degree, the sites not decided by gullies and not too stony. Then classification of bench terrace is level bench terrace sloping outward, sloping inward. The diagram will show that it is an leveled bench terrace, then bench terrace of outward sloping, bench terrace of inward sloping. The water which is to be removed through some ditches, it is to be constructed based on that level land slope. They will make the bench terraces based on these three types of diagrams. Then design specification of bench terraces: type of bench terrace, spacing of bench terrace, width of bench terrace, terrace cross section. Then that spacing of bench terrace is determined by using this equation 0.3 into s divided by 2 plus 2. Using this equation they will find out W is equal to 20d divided by s, where W is the width of terrace, d is the depth of cut, s is the percentage of land slope. Then determine the vertical interval. Vi is equal to W into s divided by 100 minus s. For the slope 1:1, for the slope half is to 1, 2 into W into s divided by 200 minus s. This equation is utilized. Then Morgan formula is there for finding out the vertical interval length. Then grassed waterways to remove the excess runoff from the terraced field, bunded field, or from the conservation treated areas to conserve the rainwater down the slope to safe place to reduce the soil erosion runoff. The design parameters are size of waterway, shape of waterway, flow of velocity. So these are the some cross section which is recommended for the waterways. The most economic way is trapezoidal section is the better way for extracting the water. In some cases half semicircular, in some cases triangular they will prefer for extracting the excess water. Then design procedure is there. Design procedure and problem will be discussed in our day-to-day classes, regular blackboard classes. Then design of gabion structure have an construction cost which is having this kind of concept parameters are there. The size of the gabion box, capacity of the box, area of the wire mesh, density of the wire used, cost of mesh construction, labor charges, cost of rock filling. So it contains these kind of procedures are there. The next one is wind erosion within the range of natural occurring wind velocity. The critical velocity for wind erosion to take place found in the following four groups: velocity at which the soil particles begin to move on the surface of the soil, velocity at which the saltation of the particle will take place, velocity at which particles begins to sediment, velocity at which motion of particles will steps likewise is there. Then next one is transportation distance of particles is determined using this equation: I is equal to h divided by tg into alpha. Then area protection from the wind break, that is d is equal to 17 in divided by v30 divided by v into cos theta. So based on that we can protect our field for soil erosion. So up to this our unit 3 will be over. Thank you.